In this section, we are going to be discussing environment, atmospheric, and volumetric effects in V-Ray, and in this lesson particularly, we'll be taking a look at environment fog. V-Ray environment fog is an atmospheric effect that simulates fog, haze, atmospheric dust, and other atmospheric aerosols. The scene I have here is from the volume 30 of the Arc Exterior collection by Evermotion. We are gonna spend a very small amount of time here to explain how to set up environment fog, and then we'll be headed to our next scene to explain different parameters of this effect. The current scene won't be provided with the project files, and if you like it, you can head over to evermotion.org and buy the scene. To add environment fog to your scene, simply from the rendering menu, go to the environment window, come down, and from the atmosphere section, click on this add button and add environment fog. And if you select the environment fog itself, you can see and adjust all of its parameters. The first parameters I want you to look at are fog distance and fog height. Fog distance controls the fog density. Larger values make the fog more transparent, while smaller values make it more dense. And fog height, as the fog is supposed to start from a certain Z level height and continue downward indefinitely, this parameter determines the starting point along the Z axis. I know that 100 centimeter for the fog distance is gonna give us a very dense environment fog for this scene. So let me increase it to something like 5,000 centimeters so we get a more transparent fog. And for the fog height, I know the house we have in the scene is about 8 meters and we have these huge trees. Let's use a height of something like 10,000 centimeters. Now if I go to the frame buffer, the first render was done without environment fog, and as you can see we get a clear image. And in the second render, environment fog was active with the current settings that we have. Maybe the fog effect is a bit exaggerated, but we can make the fog more transparent by increasing the fog distance even more. Let's set the fog distance to 10,000 centimeters and see what we get. And as you can see, compared to our previous render with the fog distance of 5,000 centimeters, we get a more transparent fog. In the next render, fog distance was set to 20,000. Again, more transparent fog, and in the next render it was set to 50,000. And if you compare this final render to our first render with the fog distance set to 5,000 centimeters, we get a huge difference and obviously less dense fog. And here is our final render with full HD resolution with fog distance set to 5,000 centimeters. Let's just apply some quick color corrections. Enable exposure and set the exposure to something like 0.7. Enable white balance and set it to something like 8,000 so we get a warmer render. Enable color balance and make the shadows a bit cooler, maybe something like 0.14, and the highlights all the way to the yellow side. And this can be our final render. Now let's open up the specific scene for this lesson and start going through all the environment fog parameters. In this scene, which is 0901 environment fog start, we have this very simple scene. We have this box as our main subject, a main light that is coming from the right side, and a secondary light that is coming from the left side. And if we render the scene right now, this is what we are going to get in render 01. Now let's go to the environment and effects window and add V-Ray environment fog. Now if we render the scene without changing anything else, this is what we are gonna get in render 02. And obviously we are going to get our environment fog effect, right? The first parameter I want to talk about is fog height, and we know fog height is the point where the fog starts on the z-axis and continues downward indefinitely. The box we have in the scene is 30 centimeters on each side, so if we decrease the fog height to something like 10 centimeters and also decrease the fog distance to something like 30 centimeters, so we get a denser fog, and render the scene, we get render 0, 3. And now we can see where the fog actually starts, which is 10 centimeter point along the z-axis. Let's get back to the environment and effects window. Set the fog distance and fog height to 100 centimeters, which is their default value. To discuss the rest of the parameters, what I want to do is to confine the fog effect to be only visible inside this box. And to do so, what we can do is to come down and add the box to this gizmos list. So let's click on this add button, press H and select the box. Now we need to hide the box in the Explorer to be able to actually see the fog effect. Let's hide that. Now the environment fog effect will only be visible inside this box, and as you can see, the fog height parameter is grayed out, and wherever the box is, the fog effect will be in there. Also, let me decrease the fog distance to something like 5 centimeters so the fog would be more dense inside the box. And if we render the scene right now, we are going to get render 0, 3. The first parameter we have is the fog color, and this is the color of the fog. Obviously we can use a simple color or use a texture. Down here in the maps we're allowed to control the color of the fog. Let's change the color to a color like 38, 217 and 190. Render the scene, and we're going to get render 04, in which the fog color is this turquoise color. Or we can use a texture to control the fog color. So let's open up the material editor. And create a gradient ramp map. Change the first color to a pinkish color like 210, 30, and 174. For the second color, we can use a turquoise color again, like 10, 115, and 127. And for the third color, let's use a yellow color like 231, 255, and 24. Also, let's make sure the mapping type is set to planner from object XYZ. Now we can use this map as the fog color map. Okay. And if we render the scene right now, we're gonna get render 05, and as you can see, the gradient map has been applied to the fog color. Let me disable fog color map for now and change the fog color back to its default color, which is a white color with a value of 217, and press OK. We discussed fog distance. We have fog emission, and this option controls the fog emission or self-illumination. Obviously, if we render the scene with fog emission color set to black, we don't get any self-illumination from the fog, as we can see in the frame buffer. Now, first let's try a medium gray color as the fog emission color and render the scene. As you can see in this render, we get a visible self-illumination quality in the fog. And for the next render, let's set the fog emission color to an orange color with the R, G, and B values set to 188, 109, and 52. And right now, the self-illumination property has an orange hue. Let's set the fog emission back to black for now. We have scattered GI and scatter bounces. Scattered GI, when enabled, the fog will also scatter global illumination. This can obviously slow down the render in more complex scenes, and in most cases we can use fog emission color instead of the scattered GI option and get quite similar results without that much increase in render time. And scatter bounces controls the number of GI bounces inside the fog when scattered GI is enabled. In the first render, scattered GI is off. Now we can enable scatter GI and set the scatter bounces to 1, and this is going to be our render. And in the next render, scatter bounces was set to 4, and as we have more GI bounces here, the fog looks brighter obviously. In this case, let's leave the scatter GI enabled and set the scatter bounces to 1. Then we have subdivs, and when you don't use any textures in the maps rollout to control fog color, fog density, or fog emission, subdivs controls the overall quality of the fog effect and basically determines the number of points inside the fog at which volumetric lighting is evaluated. Smaller values for this parameter render faster but may produce noise in the image. Higher values render longer but with less noise, and obviously image sampling is going to affect this volume. Now what I want to do is to enable the fog color texture again and control the fog density parameter with a simple checker pattern. So in the material editor, add a checker texture, set its mapping to planar from object XYZ, and its styling to 5 and 5. Now we can use this checker as the fog density texture. Also, let me set the fog density to something like 2 centimeters so we get a more dense fog effect, and if we render the scene, we are going to get render 0.6. When we actually use a texture to control fog color, fog density, or fog emission, the overall quality of the effect will be controlled using step size, texture samples, cutoff thresholds, and max steps parameter. And let me quickly quote V-Ray's guide on these parameters. Ray matching sampler is used when any of the fog properties like color, density, or emission is mapped with a 3D texture. The sampler steps through the volume, evaluating volumetric textures and lighting until it leaves the volume if there are atmospheric gizmos specified, or until the accumulated volume transparency falls below a certain cutoff threshold, or until a specified number of maximum steps is reached. Step size determines the size of one step through the volume. Smaller steps produce more accurate results but are slower to render. In general, dense volumes require smaller step sizes than more transparent volumes. In practice, step sizes that are 2 to 3 times smaller than the fog distance parameter work well. We have texture samples, which determines the number of texture samples for each step through the volume. This allows to sample textures more accurately than the volumetric lighting. It is useful in cases where the texture vary much faster than the lighting itself. And cutoff threshold controls when the ray matcher will stop calculating the volume. If the accumulated volume transparency falls below this threshold, the volume will be considered opaque and tracing will be aborted. Higher values make the rendering faster but may introduce artifacts. And max steps specifies the maximum number of steps through the volume. Let's set the step size to 16 and take a look at the frame buffer. As you can see, with the step size of 16, we get a very noisy and inaccurate result. The step size of 4 was used in the next render, and we get more accurate result, but still there are some problems in the shading, as you can see. We already know that values for the step size that are 2 to 3 times smaller than the fog distance parameter work okay in most cases. The fog distance is set to 2 centimeters right now, so a step size of 1 or 0.5 centimeters should give a more accurate result. So in the next render, step size was set to 1, and the result is much better and the shading is more accurate, but if I zoom in, we still get some shading problems. And finally, step size was set to 0.5 centimeters, and this value gives us perfect results. We have gizmo fall-off radius, When this value is larger than 0 and the fog effect is contained within a gizmo like the box object that we have here, this option allows you to specify a fall-off radius for it. This way the fog effect does not have sharp edges at the edges of the gizmo. In the first render, fall-off radius was set to 0 and we get our normal render with sharp edges. In the second render, fall-off radius was set to 20 and now the edges are becoming more transparent. And finally, fall-off radius was set to 20. Now let's set the fall-off radius to 0 again. We have gizmo fall-off mode, which allows you to choose between two different fall-off modes, multiply by density and add density to fall-off. We have gizmo merge mode, which specifies how overlapping gizmos are rendered, either overlap or blend. If you just unhide the box and shift and drag it to have a copy, let me set the exposition of the second box to 17 centimeters. Now let's add the second box to the gizmos list and now hide both of the boxes. Now if you render the scene right now, the first render here in which merge mode was set to overlap, and in the second render it was set to blend. You can see just a bit different in this overlapping areas. Let's set it to overlap again. Deep output, if enabled, allows for deep EXR output of the fog effects. We have maps rollout that we discussed. In the ray filter section, you can determine what rays are affected by the environment fog effect. Affect background: when disabled, the background will not be obscured by the fog. Affect reflection specifies whether the fog will be rendered in reflections or not. Affect refraction specifies whether the fog will be rendered in refractions or not. Affect shadow specifies if the fog should affect shadow rays, and affect GI specifies if the fog should affect GI rays, and affect camera rays specifies if the fog will be visible to the camera rays. In the nodes rollout, we have two lists. In the gizmos list, we can add as many objects as we want, and the fog effect will be confined within those objects. Make sure to hide those objects that you add to this list, or make them not renderable to see the fog effect. In this case, let me remove box 002 from the list. And if this list is empty, we get the fog effect in the entire scene based on the fog height parameter. On the right side, use all lights is enabled, so all the lights in the scene will affect the environment fog right now. I can disable this option and pick only those lights that I want to affect the environment fog. So click on this add button, press H and select only the main light. In the frame buffer, the first render was done with use all the lights enabled. So here we are using both the main and the fill light. And in the second render, we are only using the main light to affect the environment fog. As you can see, the left side is getting a bit darker. Now let me remove the main light from the light list and enable use all lights again. For the final render, let's create a quick 3D checker pattern. So open up the material editor, shift drag to copy the current checker pattern and rotate it on X by 90 degrees. Let me add a new composite map. Connect the first checker pattern to layer 1 and the second one to layer 2, and set the blending mode to for the second layer to multiply. Now if we connect the composite map to the fog density, we are gonna get a 3D checker pattern in the fog effect. Now let's take a look at a few final renders. This is our first final render. Now let me go to the denoiser pass, and here the original texture pattern was used. In the next render, the composite of the two checker pattern was used and we get this 3D checker pattern. And in the next render, I changed the black color in the checker maps to a medium gray. And you can see the result in the frame buffer. Now I invite you to go ahead and try different maps for fog color and fog density and have some fun on your own. So in this lesson we learned about environment fog, and I will see you in the next lesson. Okay guys, in this lesson we talk about aerial perspective, which simulates aerial perspective effect. Basically, the effect the atmosphere has on the appearance of an object as it is viewed from a distance. As the distance between an object and a viewer increases, the contrast between the object and its background decreases, so those faraway objects will look fainter and hazier. This atmospheric effect works together with very sun and very sky to calculate an approximation to the aerial perspective effect. Sometimes environment fog can be replaced by aerial perspective, and it is faster compared to environment fog, but it is not as accurate as environment fog, and it cannot produce volumetric shadows like environment fog, which makes environment fog that interesting and realistic. In this scene we have a simple city model. Some simple buildings here and there. The camera is here and the sun is on the other side. And this is the render we get if we render the scene right now without aerial perspective. Okay, now let's add aerial perspective. From the rendering menu, go to the environment and effects window, and in the atmosphere rollout, add V-Ray aerial perspective, and now let's run the active shade. And we get our aerial perspective. We have some haze, the buildings in distance look less contrasty. Now the first option I want to enable here is affect environment rays. So the aerial perspective affects very sky in the environment if this option is enabled. And now we can see in the active shade that the aerial perspective affecting the very sky and makes it hazy. The first parameter here is visibility range in meters. This specifies the distance at which the fog has absorbed 90% of the light coming from objects behind it. Lower values make the fog appear more dense, while larger values reduce the effect of the aerial perspective. Let's start with 50,000. As you can see, the effect is less visible. Let's try 20,000, 10,000, 5,000, 2,000, and 500. So as we decrease the visibility range, we increase the effect of the aerial perspective effect. For now, let's set it to 500. We have atmosphere height, which is basically like the fog height parameter in the environment fog, and it defines where the aerial perspective starts on the z-axis. So if we use something like 25 meters, you can see the effect starts at 25 meters on the z-axis and continues downward indefinitely. Maybe let's try 10 here. Now let's set it back to 6,000 meter and set the visibility range to 2,000 meters. We have in scatter light intensity, which controls the amount of sunlight scattered from the atmospheric effect. The default value of 1 is physically accurate, and if I increase this value to something like 2, now because more sunlight scatters through the atmosphere, we get a brighter effect, even though not quite accurate. Let's set it back to 1. On the other hand, if I decrease it to something like 0.1, less sunlight scatters and we get a darker effect. You can see we can create some beautiful renders using this value. Let's set it to 1 for now. We have affect environment rays and affect background. When enabled, aerial perspective will affect the environment, and if we have anything else other than a V-Ray sky in the background, affect background controls whether aerial perspective affects that background or not. We have filter color, which affects the color of the in-scattered light and basically controls the overall color of the aerial perspective effect. Let's try different shades of blue maybe. Try some warmer shades. Maybe different shades of gray from darker tones to brighter tones. Now let me stop the active shade, and here we have some final renders with different aerial perspective settings. Just adjusting filter color, in scattering, while you visibility, range amount and stuff like that. You can go ahead and experience and create different looks. Maybe we can add some curve correction to this second render, and I'm gonna do that for all the renders and try to just simply adjust their contrast using a curve correction and save them out. Okay. So that's about aerial perspective, and I will see you in the next lesson. In this lesson, we'll be taking a look at V-Ray Toon Render Effect, which is a very simple atmospheric plugin that produces cartoon-style outlines on objects in the scene. If I open up the frame buffer, this is the render we get from the scene right now. As you can see, there is no atmospheric effect here. Now, in order to add V-Ray Toon, from the rendering menu, open up the Environment and Effects window. And from the Atmosphere section, you can add V-Ray Toon. Now, without changing anything, if you render the scene, we are going to get render 01 and these black outlines on our objects in the scene. V-Ray Toon has some simple and self-explanatory parameters, and I'll be going through the more important ones here. Line color controls the color of the outline, obviously, and if we change it to this red color and render the scene, we are going to get render 02 in which the lines are red. Down here we have two units to control the width of the lines in pixels or in world units, which is currently set to centimeters. In the world unit, lines closer to the camera will be thicker, so we're gonna get perspective. Let's increase the width of the outline to 5 pixels, which gives us render 03. You get thicker lines. Opacity controls the overall opacity of the outline. If I set it to 0.5 and render the scene, we get render 04. And the red outlines are less opaque in this render. Let's set the opacity back to 1. We have hide inner edges. When this option is enabled, the inner edges of the geometry won't be considered for the calculation of the edges texture. And if we render the scene right now, you can see in render 05, the inner edges have no outline. Let's disable hide inner edges for now. And down here we have maps for all to control parameters like color, width, distortion, and opacity with a texture. For example, let's open up the material editor and create a noise map. Change the mapping to world XYZ. Set the noise type to fractal and size to 10. Now we can use this map to control something like maybe the opacity here. And if you are using a map to control these parameters, make sure the mapping type is set to world XYZ or screen. And if we gonna go ahead and render the scene, we're gonna get render 06, and we get varying level of opacity based on the noise map that we have defined. And down here in this exclude section, you can exclude certain objects from the toon effect, and this way you can add more toon effects and make sure they are only applied to certain objects. For example, maybe you have a sphere in your scene and you want to have a black outline on that sphere instead of this red outline. So you can simply exclude that sphere from this toon effect and add another toon effect and make sure the color in there is black, and this way achieve what you want. So you can have multiple toon effects in your render simply. In this lesson, we learn about V-Ray toon effects to produce cartoon style outlines on objects in the scene. See you in the next lesson. In this lesson, we take a look at V-Ray volumetric grid. And if put in simple terms, this is V-Ray's way of importing grid-based cache formats, adjusting their shaders to your hard content, and rendering them. At the time being, V-Ray volumetric grid supports three very popular volume formats for generating fire, smoke, and liquids. OpenVDB or .vdb files, Filled 3D or .f3d files, and PhoenixFD or .aur files. Probably the most used one is OpenVDB or .vdb files that can be generated in a software like Houdini or directly inside 3ds Max using a plugin like FumeFX. In order to add a V-Ray volumetric grid to your scene, in the Create panel and Geometry tab, choose V-Ray, and here you have V-Ray volume grid. Simply select it and click once in the viewport. As soon as you do that, you will be prompted to select the volume file that you want to render it using V-Ray. Now here we need to define a file or a sequence of files that are .vdb, .f3d, or .aur files. And if you go to openvdb.org and go to their download page and come down to their sample models, you can download some .vdb files. Go ahead and download this bunny cloud file, this explosion, this fire, smoke 1 and smoke 2, and save them somewhere on your disk. Even though we're just going to be using the explosion file, the fire file, and smoke 1 again, but still try and experiment with the other models. Now I have them in my project files folder, scene assets folder, inside a folder called OpenVDB. Just rename those smoke 1 and smoke 2 files and make sure to remove the numbers at the end of their names, so V-Ray wouldn't consider them sequential when we load one of these files. In this case, I renamed smoke 1 to smoke and smoke 2 to smoke puffy. In this case, let's select this fire.vdb file. When you do that, V-Ray asks you if you like to use a render preset for the file that you are loading. So if you have done the fire and smoke sim in FumeFX, you can use this FumeFX preset. If done in Houdini, use the Houdini fire and smoke preset, and if it is a liquid simulation, you can use Houdini liquid, or you can choose no preset and start adjusting the volume from scratch. Also, we can later on load any of these presets and even use a PhoenixFD preset, but for now, this is okay. Now, as you can see, the file, which is this fire simulation, has been loaded into the viewport, and we can see a preview of what the sim is looking like in the viewport. This is just one single file, and if I go through the timeline, it does not change. If we had a sequence of volume files, we just needed to select the first one and we would have loaded the complete simulation into the timeline. First of all, let's make sure it's in the right place and has the right size. So it basically matches with the current lighting that we have in the scene. In the top view, let's move the file and place it close to this dummy object. In the perspective view, increase its scale to 350%. And in the front viewport, just put it on the backdrop and offset it on x-axis by 5 centimeters so it would be centered. Also, let's rename this volumetric grid to Vray volume grid underscore fire. If we render the scene right now, we are going to get render 0, 1. If there was any warning message about fully visible opacity mode not working with probabilistic shading and Vray asks you to automatically use smoke opacity mode, just press OK. In this render, even though the fire and smoke shaders are quite off, but at least we get something in our render. In order to adjust the fire and smoke shaders, select the volumetric object in the Explorer, and in the Modify panel and Rendering Rollouts, click on these volumetric options. And here you can adjust the fire and the smoke shaders and make them appear correct. But before getting into that, let's see what options we have in the Modify panel and what we can change about our volume here. If I open up these rollouts here, you can see we have a lot to adjust and understand here, but due to the time limit that we have, I'm just going to go through the most important ones. In the frame info rollouts, you can see some information about the cache file or the volume file that you have loaded. We have the container dimension, which shows us height, width, and depth of the volume. We also have this cache file content section, and here you can find what are the channels that are saved out in this volume file. For example, this particular file contains a liquid or a temperature channel and a smoke channel, and it has about 9 million cells, and it might seem too much, but it's really not. And you know, we can't even get a detailed render because the input file simply doesn't have enough resolution, but we're going to work with this file for now. Next, we have the input rollout, and here you can adjust the input file or the timing and the speed of the simulation and stuff like that. The most important option here is obviously preview and render cache path, and here you can define and change your input file. The file that we selected when we first created the volume grid, basically. So I can click on this browse button, choose browse again, and select my volume data if I want to change it or create a new one. I'm gonna skip the rest of these options in this rollout here. They're basically beyond the scope of this introductory course, and if you are interested, you can check out Vray's guide and explore what each option is doing, and some of them like place start and place speed are very self-explanatory, and most are for when you have a sequential volume data in your scene. In the preview rollouts, you can determine how the volume is displayed in the viewport, and the options in this rollout wouldn't affect the final render in any way. We have detail reduction as we increase this volume, let's say to something like 5. We get a less detailed preview of the scene in the viewport. If you had a very huge volume file with hundreds of millions of cells and your interface became sluggish, you can increase detail reduction so to make your interface and viewport more manageable. When set to 1, no detail reduction is performed in the viewport. Let's set it back to 1 for now. We have auto reduction, enables automatic adjustment of reduction in detail due to the detail reduction setting. The preview detail will be reduced to the point where the preview will display fast without blocking the interface. Note that the detail will only decrease automatically but will not increase. We have show mesh, and if I enable it, we see a mesh representation of the volume. Let's disable it for now. In the cell preview section, we have only if selected, and when this option is enabled, you have to have the volume selected to see the preview. If you want the volume to be visible all the time, simply disable this option. We have active view only, and when enabled, the volume preview will be only visible in the active viewport. In this colorful section, we can control what we see in the preview. We know this cache file only contains temperature and smoke channels. First of all, let me disable the preview for all the channels. I can enable temperature channel and change its preview color, and I can enable smoke data and adjust its preview color. And we don't have velocity, fuel, or wavelet channels in this file, so let's have them disabled. In the rendering rollout, we can define how the volumetric grid will be rendered. We have render presets, and we can choose from FumeFX, Houdini, or Phoenix FD. presets, and if I open up the volumetric options window, you can see as I change these presets how the fire and smoke colors are changing, and also they affect other render settings. In this case, let's choose Houdini preset. In the mode dropdown, we can specify the technique that will be used to render the volume data. The first three ones are volumetric based, and the last three ones are mesh based for rendering liquid simulations. So if the mode is set to volumetric, which is the mode we probably use it most of the time, as you can see in the frame buffer, we get our conventional volumetric render. And if I set it to one of these mesh based modes like isosurface and create a new simple VRA material in my material editor and apply it to the volumetric grid, now we are gonna render the scene. We're gonna have a geometry in the render instead of the volume, which, as I mentioned, can be used for liquid sims. Let's set the mode back to volumetric. We have the volumetric options window, and here we can control the fire and smoke shaders and the overall opacity of the volume, which we discuss in a moment. Let me close it for now. We have this step size, and it is only effective when the mode is set to heat haze or isosurface, and basically smaller values will preserve more detail of the volume in the render, and higher values will skip some of the cells and might result in less details or artifacts in the render. And using shadow step, you can define how much detail you want in your shadows. Lower values will result in more detail preservation but higher render time, and vice versa. In the frame buffer, the first render was done with shadow step set to 200, and the next one with shadow step set to 10, and we get more detailed shadows in the second render if you pay attention closely. And obviously we need to render the scene for a longer time when decreasing shadow steps to get a clean result. Let's set the shadow step back to 200. In this surface section, if the mode up here is set to one of the mesh-based modes, you can determine how the conversion of the grid content into geometry will happen based on what channel this conversion is going to happen, and some other settings like that. In the motion blur section, you can define how motion blur effects will appear in the rendering of the volume, and you can multiply the effect using this multiplier, obviously. Using this displacement section, you can add more detail to your volume. This can be useful if you don't have a high-res sim but still want to have more detail in your simulation and in your render. And the idea of displacement mapping here is the same as displacing a geometry using a VRA displacement modifier. You define a map, and based on that map, the volume will be displaced, and you would see more details in your render, even though they're gonna seem a little bit fake. So in this case, let's enable displacement. Use vector as the displacement type. Open up material editor. And add a noise map. Change the source to world XYZ and size to something like 5. Now you can use this as the displacement map. Let's increase the multiplier to something like 15 so you can clearly see the effect. In the frame buffer, the first render was done with displacement disabled, and in the second render it was enabled. It's a bit exaggerated, but you can clearly see the difference and how this option has the potential to add a lot more detail to your renders. In this case, let me just disable displacement for now. We can open up our volumetric options and start working on the fire and smoke shaders. Let's open it up. In the fire rollout, we obviously control the fire shader and how it looks, and also the light emitted by the volumetric grid. The first thing you need to look at is this based on dropdown, and here you can define the source channel that will be rendered as fire. In this case, we only have temperature and smoke channels, and by default it's set to temperature, which is correct. In this emits light section, we can control how the light emitted from the fire affects the volume itself and also the scene illumination. We're going to take a look at these options in a moment. And down here you can control the overall opacity and a multiplier for the fire intensity. And using this gradient you can control the color of the fire, and using this diagram you can control the intensity or opacity of the fire. Let's add a few color and see how they appear in the render. But before that, let's delete the current points and colors here. Simply select the point, right click and delete the selection, except for this block color maybe. We can click on this expand button and expand the diagram a bit so we can work a bit easier. Also right click and choose fit in view so we only see the data range for the current channel, which is temperature, and its data range is between 0 and 44, 45. Between 40 and 45, but a bit closer to 40. Double click to add a point and use the following values for R, G, and B as the color of this point. So 0.978 for red, 0.844 for green, and 0.605 for blue. Add the second color on 40 and use 0.978 for red, 0.626 for green, and 0 for blue. Basically what we are doing here, if you select the volumetric grid and go to its frame info rollout, you can see the temperature channel that we are currently using as the source for the fire has a data range from 0 to 45. And if you take a look at this diagram here, as you are going from 45 to 0 and change the colors at that range, we are specifying the color of the fire at its highest point, which is 45, and to its coolest point, which is 0, or its lowest point. I hope it makes sense. Now add another point in 35 and change its color to something like 0.978 for red, 0.482 for green, and 0.014 for blue. Click on 25, set the red value to 1, green to 0.122, and blue to 0.036. Now click on 20, use 0.388 for red, 0.014 for green, and 0 for blue. Also click on about 7 and use 0.338 for red, 0.022 for green, and 0 for blue. Now if I render the scene, we are gonna get render 08 in the frame buffer. You can see the colors we have defined are there, but this white smoke won't allow us to see the fire very good. So let me go to the smoke color section and change the constant color of the smoke to a dark gray with a value of 75. And if we render the scene, we are gonna get render 09. And now we can clearly see the fire, and as you can see, there is a direct translation between the color that we defined in the gradient and the colors that appear here in the fire. You can see these brighter yellow colors, then we get this yellowish color and this orangish color and those darker colors at the edges. The next problem we have is that our fire is not intense enough. So let's use the fire multiplier value to make the fire more intense. Let's try 0.6 here. And if we render the scene, we are gonna get render 10. Now it is more intense and looks more realistic. Okay, now let's take a look at the most important parameters that we have in the fire rollout. First we have emit light. The fire will emit light both on the smoke and on the scene. But if disabled, the fire becomes a simple self-illuminated object and it does not emit any light. In the first render, emit light is on, and in the second render it is off. And as you can see in this render, the fire isn't emitting any light. Let me enable emit light for now. We have light power on self, and this option controls the power of the light on the smoke. So by changing this value, we don't change the intensity of the fire itself or how much it affects the illumination of the scene, only its effect on the smoke. In the first render, light power on self was 1, and in the second render it was 10. And you can see the clear difference that we have. For now, let's leave it at 10. We have light power on scene, which controls the effect of the fire on scene illumination. In the first render, light power on scene was 1, and in the next one it was 5. You can see clearly the fire affects the illumination of the scene more. Let's set it to 1 for now. We have fire opacity mode with 3 options. We have use smoke opacity. Fire will use the same opacity that is set to the smoke in the smoke opacity rollout. This way the fire will not be visible in cells where there is no smoke. Fully visible. In this mode, fire will always use an opacity of 1 regardless of the smoke's opacity. And when set to use own opacity, a varying opacity can be set for the fire using the opacity diagram. In this case, it really doesn't matter. Let's set it to maybe use smoke opacity, which is going to result in render 17. We have physically based, which transitions between artistic look of the fire when set to 0 and realistic physically based intensity when set to 1. The realistic mode multiplies the fire intensity by the black body radiation model, which gives strong brightness to the hot parts of the fire. In the first render, physically based was set to 0, then 0.3, then 0.5, and finally 0.75. In this case, let's set physically based to something like 0.3. In the smoke color rollout, we can control the smoke shader and how the smoke will appear in the render. In the based on drop down, we can define the source channel to control the smoke color. By default, it's set to constant color. So a simple color will be used as the smoke color, and this is normally what you use. And in this constant color section, obviously you can define the color of the smoke, and it really depends on the look that you are after, but normally a dark gray color will be enough. In the first render, smoke color was set to a dark gray with the value of 30. In the next render, it was 75. And in the next render, a medium gray color with the value of 150 was used. And you can use obviously any color that you want, for artistic reasons maybe. In this case, let's use a dark gray color with the value of 75. Or you can change the source to smoke channel, and now you have this gradient to control the color of the smoke based on the data in the smoke channel and assign different colors to different ranges. And if I render the scene right now, we're going to get render 25, and you can see how the colors in the color gradient are translated into the smoke colors in the render. We're going to use this gradient to produce some beautiful colorful smokes later on in this lesson. For now, let's set the mode to constant color again. We have this master multiplier, which is a general multiplier for the smoke color. The first render was done with master multiplier set to 1. In the next render, it was set to 2. And finally 4. You can see we get brighter smokes basically. Let's set it to 1 for now. Using shadow strength, you can control the opacity of the shadow that the volumetric casts on other objects. And finally, in the smoke opacity rollout, we can control the overall opacity of the shader. By default, it's set to simple smoke, which uses the smoke channel with some predefined adjustments. And in this case, you can use this simple smoke factor to make the smoke more opaque or denser. So let's try a few simple smoke factors value. In the first render, smoke factor was 0.1, then 0.3, 0.5, 0.75, and 0.95. And as we increase simple smoke factor value, each time we get denser smoke. Let's leave it at 0.95 in this case. Or you can change it to the smoke channel and have a very exact control over the transparency of different data ranges in the smoke channel using this diagram. For now, let's set it to simple smoke. If you come back to the fire rollout, we have this parameter called light resolution, and let me quote VRA guide on this one. Light resolution specifies the resolution of the light grid as a percentage of the fire grid. Perfect illumination from fire could be achieved by placing an omni-light in each fire cell, but this could take a tremendous amount of time to render and is usually not necessary. For this reason, a separate light grid is created internally which can have a lower resolution than the fire grid, and this light grid is populated with an omni-light in each cell. The lower resolution and thus fewer omni-lights speeds up rendering at the expense of some illumination detail, which might not always be visible anyway. At a value of 100%, the light grid has the same resolution as the fire grid. The more this value is decreased, the smoother the illumination will become and the faster the rendering will be, but at very low values, the fire might not blend well with the light it casts on the smoke. Now, in the first render, light resolution was 1%. In the next one, it was set to 5%, and immediately we get more accurate result. As you can see, more accurate illumination overall. In the next render, it was set to 10, and finally 20. Let's, in this case, set the light resolution to 5, also light power on scene to 5. And if we render the scene right now, we're going to get render 38. Okay, that is enough for this shader. Now let's go ahead quickly and work on some other shaders and have some fun. Let me close this window for now and create a new V-Ray volumetric grid. Let's load this explosion.vdb. And adjust its position a bit. If we render the scene right now, we are going to get render 39. Now let's open up its volumetric options and start adjusting the shader. In the smoke color rollout, change the color to a dark gray color with a value of 51. In the smoke opacity rollout, set the simple smoke factor to 0.75. And now if we render the scene, we are going to get render 40. In the fire rollout, you can see the data range for the temperature channel is very limited here. First, let's change the fire opacity mode to use smoke opacity. Click on this expand button, right click and choose fit in view, or you can scroll your mouse wheel on the color gradient and zoom in on the available data range that you want. Double click at about 0.8 on X, basically the end of the data range here, and make sure it's set to 1 on Y. Also right click on the point and make it linear. Now we have this linear line to control the overall intensity of the fire. Also right click on the color gradient, select all, and then delete all the color points. Double click at about 0.5 and let's choose a hot yellow color like 0.906 for red, 0.554 for green, and 0 for blue. Now click at about 0.45 and let's use a very saturated orange color like 0.993 for red, 0.144 for green, and 0 for blue. At about 0.25 let's use a very desaturated orange color like 0.05 for red, 0.009 for green, and 0 for blue. Create a new point at 0.0 and set its color to black. These colors and values that I'm using here aren't magic colors and numbers. You need to experiment with your scene and find out which color and which intensity will work best for your particular volume data. Now let's set the multiplier to something like 10, the fire multiplier. And if we render the scene, we are gonna get render 41, which is not too bad. And finally, we can increase light power on self to 10, light power on scene to 5, and light resolution to something like 5 again. Also increase physically base to 0.5. Now, if we render the scene, we are gonna get render 42, and that's a nice render for now. Let me close these windows and hide this volume grid or volumetric grid. Now let's go ahead and add a new volumetric grid, and this time load smoke.vdb, which is smoke1.vdb originally. This time let's use no preset. Now increase its scale by 300%. Rename it to Vray volume grid underscore gray smoke. Place it in front of the camera the way you want. If we render the scene right now without changing anything else, we are going to get render 43. In its volumetric option, I'm just going to go ahead and increase its simple smoke factor to 0.75. And if we render the scene, we're going to get render 44, which I think it's beautiful by itself. Now let me hide it, create a copy from it. Just right click and choose clone and name it pink smoke or something like that. Now unhide this and open up its volumetric options. Now in its volumetric options, let's have some fun with the smoke color. Change the smoke color to be based on smoke channel. And if you render the scene right now, you can see these colors in this gradient right in the smoke, right? Now we can be an artist and choose some fun colors. Let's change this blue color to a desaturated pink like 0.59, 0.132, and 0.29. Let's delete this green point and change this yellow color to a beautiful purple like 5, 4, 6, 0.125, and 0.806. And let's change this red color to a more saturated pink, like 0.835, 0.096, and 0.351. Let me just push these 3 points apart a bit. And now if you render the scene, also let me increase my simple smoke factor to around 0.8. If I render the scene right now, we're gonna get render 46. Now let me hide this volumetric grid, duplicate it, and rename it to volumetric grid underscore orange smoke, or something like that. We're gonna be using an orange color. Unhide it. In its volumetric options, change its purple color to an orange color, like 0.878, 0.198, and 0.126. Now if you render the scene, you are gonna get this beautiful orange render, which is render 47. Oh my god, I can play with these colors honestly all night long. Let's create one final copy and rename it to V-Ray volume grid underscore green smoke. Okay, we're gonna have to change some other colors, and I'm very sorry. I know you are angry right now, but I mean, I just want to do it in front of you guys. Okay, let's change some other colors. Change the first color to 0.055 for red, 0.64 for green, and 0.5 for blue. Change the second color from the left side to 0.173, 0.764, and 0.777, and the third color to 0.096, 0.835, and 0.468. Also, let me add a pure blue color at about the end of the smoke channel range for this volume file. And if we render the scene right now, we are gonna get render 47. Now let's go through these final renders and take a look back at all the shaders that we have created in this lesson. As you can see, the render times are ridiculously fast. I mean, that's amazing, even though we don't have any GI in the scene, but still the way V-Ray handles volumetric data is just amazing and very, very fast. I haven't seen anything like that, honestly. Okay, so that's about V-Ray volumetric grid. It was very fun, and hopefully you learned something.